So this session is distributing content. We discussed how do we encode it, how do we transport it. Now, how do we actually get people see something? So our first speaker is Steve Miller-Jones from Limelight.
Great. All right, thank you very much. Good to see you all after the break. I think if I've been counting properly, the volume of equations and math has gone down consistently through the day. I think I will probably continue that trend. I started thinking about this talk in order to sort of try and pull out some of the challenges across the broader application set for distributing and delivering video. So this is going to go in a slightly different direction from low-level video that we've been looking at throughout the day. And one of the challenges we're seeing, I think, is on the edge is about moving us to a different part of the network and making access to disk, access to power, access to compute resources available. But what are we going to use them for? I was talking last night with someone who was discussing how in the NHL, for example, they're going to start using a lot of sensors on all the hockey players in 5G-enabled stadiums so that there can be a whole wealth of data about what's happening on the on the ice rink, in addition to what's happening in the broadcast stream. So the sort of question comes, how do we deal with moving data around? Where should we process things? And if we're going to see some kind of innovation in the content itself, right, in addition to how we transport the straightforward bits and bytes of the content, how are we going to deal with keeping the user experience in line with their expectations? So these are some of the quotes we can all find on the internet about the edge, and I think that's sort of the sort of starting point of what I'm going to talk about. And what I'm going to try and do is not be too high level, try and talk about sort of up front how service-oriented architectures perhaps are being used in OTT workflows, where there are pieces that can benefit from moving the processes and workloads out towards the edge of the network. And then rather than talk about how we're helping, as I've put it here, what I'm actually going to talk about is some of the challenges we're looking at with scaling some environments for dealing with additional workloads at the edge, and how we might approach computational complexity theories, how we are thinking about things like resource scheduling, so that we can provide some kind of environment that scales for compute as much as we can provide environments that scale for distribution of content. So in the distribution part, I'm talking about both, how does access to compute sort of fit alongside the distribution path. So I hope you find that interesting. So, these are sort of my favorite definitions of the couple of these things, so I can just level set where I am, where I'm talking about. These are easily findable with a pretty simple Google search. But, edge computing being this paradigm where we're putting storage, disk, power, compute resources closer to quotes where it's needed. The point being that we're trying to improve some part of the response time and actually ultimately save bandwidth as well. So if we think about centralized clouds and how much data is going to be processed there, if we think about our NHL hockey players with sensors on them example, do we want to send all that data up to a central cloud, use all that bandwidth there to do processing just to send it back? Or do we want to do some kind of incremental processing in some so-called fog layer, discard the raw, and send forward the aggregated or computed results? So, I think the concept of where the edge is, where I'm talking about, is in the last mile network located next to the distribution nodes. In our case, that's over 100 locations and growing. How can we take advantage of those to provide compute? And then we have to think about the architectures for software being used here, right? The concept of software architectures turning into somewhat granular components that are effectively talking to other components of services that are independently deployed and managed, in using a network to communicate over. That's really key. The variety of granularity in service-oriented architectures probably describes in some way where they can be put, where they should be put, the need to access state or be stateless, also probably gives some clue as to where they can be deployed. And so I think those definitions are kind of useful for us to start from. This again is a pretty high level, obviously, diagram. The point being, what we're doing in a centralized cloud location, either with cloud native applications or applications that have been ported to the cloud, or increasingly service-oriented architectures. The cloud's really great for business processes, for massive data warehousing and data lake type applications, great pieces of business logic, and these coarse-grained application processes. So for OTT, what we're all used to seeing in the cloud is typically encoding, packaging, content origin in some form. Okay, so we're used to seeing, in AWS or in any of the encoding companies who are doing cloud native encoding and packaging, we're used to seeing that deployed natively in clouds. And that's perhaps a good place to keep them. It's computationally intensive. You need access to perhaps a lot of data storage. And there's perhaps a lot of business process you want to apply to those processes. If you think about extending that, taking that further out, what do you do there? One of the things about edge nodes is access to, of course, both local and global networks. So, in a cloud, you obviously have a global network access. In an edge location, you might have or want to only have access to a local environment, to a local ASN or a local ISP. You might also want access to point-to-point IP connectivity to talk to another location somewhere. You also might want global access. So there's the opportunity to be granular in what kind of network access you can provide. We're certainly looking at data analysis and reduction, right? The fog layer, whatever you want to call it, that layer in the ISP, where the consumers of our video content are connected to. They are, as we progress content, as content perhaps is innovated on to provide more data that goes along with the video, and perhaps in today's environment where we're looking at quality of experience metrics, gathering a lot of data, to understand what quality is being experienced, we've got a lot of data reduction we can do at the edge rather than pass it all back to the cloud. These, IoT devices, there's a lot of control plane pieces going along with how they behave and what they're doing. And these all tend to be pretty fine-grained in the cloud. Good examples of what we do in OTT today at the edge of the network are things like packaging on the fly. We've heard a bit about that earlier today. Security, DRM on the fly, forensic watermarking are things that today happen in CDNs or in clouds, on a per user or per session basis. And these are pretty fine-grained things that can happen elastically at scale in the cloud. Security beacon collection, ad insertion, any form of manifest manipulation are good candidates, I think, for happening at the edge. But one thing I think that's not really shown here, and there was some talk of it earlier today, in large live events, be that an actual live stream, or be that an event such as a series of content becoming available all at one time, these kind of events drive significant traffic from the video side, certainly. Okay, so we've all seen graphs before of here's a huge spike of traffic, on a Sunday afternoon on, choose a terrestrial broadcaster or OTT provider, when there is, Wimbledon's final and Cricket World Cup final and a British Grand Prix on at the same time, right? We see a huge spike in our traffic graphs of OTT delivered video. But what's interesting with that, of course, is it's not just the video that spikes, right? It's all of the application environments that we're watching our video on, all the different layers of our applications for authentication, for search and discovery, for data overlay, for all of the pieces of quality of experience data we're collecting that tell us about how the stream is working. All of this data is going along with the video too. So to talk about the video is obviously important, right? We have to distribute video. We have to continue to look at, what compression should we be using to reduce bandwidth in order to be efficient as more and more people are consuming content online. But we have to think about what are the demands that the consumer wants and how do we scale those things at the same time. So this is a sort of layout that I like to use to talk about application around the video. Whenever we all watch a video as a consumer, we've got to use an app of some kind. So the customer's obviously centric to that environment and what us as consumers are demanding as we're being exposed to more and more subscription or transactional or ad-led or free-to-air services is that these are really tailored to me. We like things that are tailored for myself so that I can discover content that's interesting to me quickly. I suspect in the ecosystem side, there are probably a few large organizations who are able to do and have core competencies for the entire range of services that they're providing in their OTT environment. But I suspect as well there's a lot of partnership and ecosystem going on. So the question becomes, for the partners you're choosing, if you're going to deliver your video, or the video you're carrying, or the video your consumers are watching, and there is a set of layers in your application that they're going to interact with and have data services for, or need to work just as well, are they able to scale and run those services along with your video being scaled at the same time? Use case focus is pretty important. Live streaming versus video on demand is a different thing. A live event is a different thing from video on demand. An esports tournament is a different thing from a Twitch game. There are different layers of application needed to handle these different use cases. Security is obviously key as well. I mentioned earlier on watermarking, forensic watermarking, or DRM, but think about the data security of the individual. Think about the tokenization that gets done in streaming, or DRM, or my application environment, my infrastructure. The two in the middle, everything as a service and the componentization of the front end obviously go hand in hand. I think it's clear that there is a breakdown from monolithic software into small component-based services with various degrees of granularity, but that enables them to scale on demand individually. So you don't have to scale your entire software application in order to achieve a different, a spike in logins versus individuals looking for different pieces of data, or a spike in search and discovery, for example. And then if they're componentized in the front end, it gives us the ability as people who are creating applications for end users to iterate on those individual components. A/B testing, for example, for applications for different users types and different use cases, sort of sits in there as well. I think the immediacy and the automation side of applications is important. We, as consumers, expect immediacy. We're expecting the applications we use to work, pretty quickly, or there's this phrase, we're going to go and find it somewhere else. Well, I actually suspect it's, if the application I'm trying to watch my video in or my sport in doesn't work, there might be another option depending on where I live, depending on where you are when you're trying to watch it, but I might just go and do something else. So it's all about, from an immediacy perspective, protecting the churn rates of the OTT platforms, which is really where the revenue challenge is. And in that is, of course, then automation. How do you use automation, machine learning, and other tools to provide a better experience? Standards and simplification are obviously key too. ATSC 3 is a great example of how we're seeing the standardization of the interactivity layer alongside broadcast video. And so that again leads us to think that there are significant demands that are going to be placed both on the video and on the environment that we're working in. So if we're to provide access to some kind of environment that scales on demand, there are some sort of challenges to deploying custom video workloads, right? So can we provide a scalable environment that can be used alongside, say, a CDN that enables a customer to deploy some kind of OTT workload, an authentication piece, perhaps, a specific piece of digital fingerprinting, at the edge of the delivery network so that it can be used alongside the delivery of the video? Can this scale on demand? How do you do that in a lot of different locations versus in a cloud location? And a real challenge then is making that suitable so that instantiation, a cold start, is low latency. So you're not impacting the behavior of the application, and then the execution of the workload is also efficient. So these are the kind of challenges that we're facing as we try and build an environment to help customers deploy custom workloads so that they can scale both the video distribution and the other parts of their applications. Some key questions we asked ourselves when we started down this path was, how and what parts of the OTT workflow are going to be migrated towards microservices. We know some packaging, sort of fairly coarse-grained services are service-orientated, but how is that going to move down the stack into smaller, fine-grained pieces? And what are going to be the challenges for moving from some monolith or cloud-native environment to distribute those smaller pieces so that that's part of a deployment process? Do I have a small function that I can deploy? I know how that process fits into my deployment workflows so that I don't create an enormous amount of complexity for customers when they're looking at their application deployment processes. And where do we really benefit? Who will really benefit from moving video workloads out to the edge? And these led us to two questions. Do we want to build a stateful environment? So, one that requires access to more resources to maintain state between requests, needs us to provide, as an operator of that service, to make it available, a range of different services to provide availability, reliability, and performance? Or was that outside of the scope of our concern to provide an environment for state for a customer to use with their own workload? Was it better, in fact, for us to provide a stateless environment, a simple environment for a customer to deploy their own workload, a function, if you like, to that are for the latency-sensitive parts that they determine are needed in their video workflows? And that's really where we decided to start, was to look at the serverless, a stateless environment that we could use to offer up customers to deploy functions to us that work alongside or with their video applications. So some of the core principles we looked at with this was obviously being able to distribute the function metadata and the archives right around a network. 100 locations, we've got to choose where we're going to deploy these to from a customer's footprint perspective. We need to know how to access them and fire them on demand. So we had to think about the metadata that goes with the publishing of some content and the actual archives themselves. We had to think about how the customer is going to upload code to some form of persistent storage that we can then access easily and with low latency around the network. And again, back into the customer workflow, a deployment workflow needs to have a pretty simple, straightforward access to something that's going to persist state for the content, persistent storage for that we can then later use. Moving to sort of use a different term, we're then looking at functions as service nodes, right? So we're looking at a serverless environment for functions as service. And the other key part that they've got to do is then also have a caching layer so that, for a function that's going to get used, with regularity during a period of time, but then become less popular and then get used again later on, right? We want to obviously keep some kind of caching layer for the functions themselves in a local file system, but in a stateless environment as well. And then the real challenges come in load shedding, resource management, load balancing. In an environment, how do you protect nodes from becoming overwhelmed so they cannot perform this function that you've given them at the same time that your large audience scale comes for the video? If you're going to use it for some authentication offload, or as an API gateway, or for watermarking, how do you know that you're going to be able to manage those nodes in a serverless environment where you're saying to the customer, you don't worry about the servers, we'll manage that for you, deploy your code and hit it, it will run. So load shedding, load management, resource management was key. And looking at the CDN's a great load balancer. So part of the story comes in from the CDN at a certain point, using that as a load balancer for functions. So again, a very high-level diagram, but sort of in a FAAS node for us, what we're looking at and what we're trying to architect for is an on-demand function execution environment in the network, distributed throughout the network. One that's using some combination of good open source tooling, open source environments that are tried and tested, and also, of course, custom services that we need to use to orchestrate and manage that. The function itself, the agent downloads a function file, creates a disk image, and then the disk is added to the VM as needed. What we've then got is a VM starting up a container when the function's called, and then the function runtime has then got access to the function code via the mount of the disk image into the micro VM. The VM agent is then used to forward requests into the function, And then the function runtime is there to broker messages between the VM agent and the mount, the code, and then to give a response back to the agent based on what the request was, right? So what we do in the CDN around that is we enable the functions to be aliased so that they can be routable, or routable, as I would say in England. We can offer distribution of those. We can offer scale of those. We can do some load balancing for our use cases here, and obviously caching of the results as well. Right, so these are some of the things that we put into a FAAS node. So this is, relatively straightforward. This is about as close as I get to math. This is the real problem, and the challenge that we are trying to solve for. We've got, resources in a computing cluster in some kind of availability zone. Let's call that a POP. We've got, say, 100 of those, and then how you then achieve good utilization of these computing clusters is something that I think in computational complexity theory is referred to as the bin packing problem. So what we've got to do here, everyone's function is going to be a different size, right? But we've got a fixed variable of resources available to run them in. So we've got to pack these different sized objects into a finite set of resources in a way that minimizes the amount of them that's used so that we've got access to resource and capacity for these. So I think as far as my maths goes, I think the challenge of computing this is called I think it's called a VN hard problem, and I think the outcome is called a VN complete problem. There's always going to be an answer. We're always going to find an answer. So one of the questions is how we think about the maths involved in this. There are quite a lot of articles and papers written about this problem for computing. How do you pack your functions into available resources so you know that they're available, you're not overloading things? So there's good papers available from Google, Microsoft, UC Berkeley, and they all sort of center around this concept of decentralizing everything and then being opportunistic about how you schedule availability. So we think about that, how to solve for load. What we're looking at doing with opportunistic resource scheduling is, finding the least loaded server using an algorithm based on this bin packing complexity problem, and then understanding through a feedback loop the availability of resources in that zone. So that the algorithm we've chosen to implement on deciding what instance a function should be running is based on trying to achieve this fair resource utilization across any number of customers. From our perspective, every function is a first-class citizen. From our perspective, in a multi-tenant environment, every customer is a first-class citizen. So we have to give equal weighting to their ability to run their function on demand. So, what we have to then do is also incorporate a lot of feedback about things like wait times from different nodes and so on, so that in the computation of the bin packing problem, we're actually getting, a complete answer, which we know is going to be sufficient for us to deploy and run that function in. I think the other sort of problem we've got is where to invoke, right? If we're looking at the idea that invoking functions alongside OTT delivery that are either adjacent to or part of the video delivery path, the pipeline, so say packaging on the fly, or some kind of manifest manipulation on the fly, we've got to determine where to run that function so that we're not adding latency that's unnecessary based on where the actual user is and the video is, where the video is being delivered from. So we've got to work out where to place it, and then from that perspective in the scheduling service, what we're doing is picking a number of participating servers and determining with a feedback loop what their resource availability is on an ongoing basis as they execute and before they're executing my function. And we have then this decision tree that we have to decide if we can create that function there, and then if we do, we have to incorporate feedback data so that we don't just continue choosing the same instance, for example. So our host agent starts new instances based on the requests that we get from the load balancing environment. And then to scale up and down, the agents are all sharing state of that POP, that availability zone. and then they're responsible for enabling their elastic scale themselves. They're using effectively client wait time feedback, and we have different levels of concurrency built in so that we're able to understand how to continue to build out scale for the environment that we're invoking functions in. That gives us this mix of scaling functions up and down on demand as load arrives for video distribution, based on the demand for the resources, and then other configurable items such as idle time. Idle time is really important because you don't want a cold start of the same function each time. So if you're having an event where there's a lot of requests for the same thing, you may have instantiated a number of instances for the same function. You don't want to kill them every time and then have to restart them. So all of the feedback loops, the complexity of that helps us achieve an environment that we can scale up and scale down. So from a sort of customer workflow perspective, this is, again, pretty high level and straightforward, but it sort of gives you the idea that this fits into the pretty straightforward continuous deployment, continuous integration concept that goes with standard software deployment, but then also goes alongside processes for getting a video ready and a live event ready. So it's about writing code, deploying it, and being able to iterate on that process. At the point where you're able to then publish for consumption, it's about creating an alias to point to that, but then also providing a process to go increment the version and then publish a new version, but then be able to roll back if you need to as well, and obviously deleting function. So what we then do is build a series of APIs around these workflow concepts to make sure that we're providing the right API set for customers. Bringing it back to video, what are the possible use cases that I think are appropriate for using distributed functional computing at the edge of the CDN networks? These are pretty straightforward. I think obvious ones for video, ad insertion or manifest manipulation for individual stream sessions is an obvious one. Security and watermarking, and performance beacon collection. From the web side, the applications we're working in, personalization of content, A/B testing, and content targeting. And the obvious one that stands out there is image resizing as well, being able to use functional environment to do image resizing. And then the other side of it that all comes into play, which is integral to the part, our video apps again, edge authentication, API gateways, and collecting all kinds of service data collection. So I know I'm at the end of my time. I'll leave you with this image again, which I think was useful to explain the concept. In addition to the bits and bytes of video, right, what we have is a responsibility to look after the application for the customer too. That's all part of the video experience. That's all part of restricting churn. That's all part of delivering great video. Even if they've got 8K but their app doesn't work, they're never going to appreciate it. Thank you very much.
Thank you, Steve. And we have 1 minute for probably one question from the audience.
I'm not going to answer questions about maths.
Hi, very interesting talk.
Thank you.
On edge computing, 5G talks a lot about it and operators, and right now the big dilemma for them is that how much investment they want to do at the edges and what type of functionality they can support. It's very similar discussions that you have there. One question I have is that how do you validate or approve the functions of the customers running on this? Because if I understand correctly, the functions are provided by customers and you accommodate basically resources to running them. And in terms of the amount of resources they take, whether they can run correctly, don't crash, and issues like that. Do you need an approval process? Do you need?
So there are a lot of parts of the application we've built in to create absolute isolation of each customer from each other. One of the benefits of not being stateful is I don't have to provide them the same level of access to kernel, for example, so that they can be inherently protected from each other. And then we are building a series of safeguards, if you like, both in the configuration of each client's environment and the configuration that they can control of their runtime as well. So there are things that I will control which give me security over my environment, which will ensure separation of concern for each individual customer for a multi-tenant environment, and will ensure nothing can run for so long that it kills everything. And then the customer will also have their own environmental variables that they can control their memory allocation and their their idle runtime and things like that, for example. So that, yes, that's all part of a multi-tenant environment challenge.
Thank you, and let's have another round of applause.
Thank you.